Right. Now we have x and y variables, which where we have a nonlinear relationship. Then which transformation you are going to apply? X squared or y squared? Y squared? X squared? Okay. Any other ideas? If you are going to apply the x squared or y squared? How do you figure it out? Right? How you will figure it out is, look at this. You have to get the difference of x and y. Now see, remember as I told you before, the change in x is, see, quite consistent, yes? Why? Every second it is consistent. But look at what happens to the y variable, right? What happens to the y variable, guys? Y variable, look at the change. At the beginning, change is like just a little bit, right? As it goes down, look at the change, right? Right? What is happening? The change in y is increasing, yes? Change in y is increasing. So because change in y is increasing, excuse me, Alessandro? Yes. Okay. Something else happened. Sandil, now is it okay?
Yes, sir.
Okay. I hope now it's okay. Right. Okay, guys. No. What transformation would we use here? X squared. Why? Because the change in x is quite consistent, but the y change is increasing. So to match the increase in the increase in the y, we have to stretch out the x. So then we would use the x squared. Okay, right. Then yeah, then what we are going to do is we will get the y value. Yeah, we'll get the y value, and then we will get the x squared. So we will square it. Right? These values would be squared, and then we are going to plot, right? 1 will be anyway 1. What is this 10? Times squared, yeah. So 1 will be 1, and then 2 will be 2 squared will be 4, 3 squared 9, like that. 4 squared 16, like that we are going to do. Sorry? Because 10 squared 100, which is here. Okay, so what we are going to plot is 10 squared, and what is the value here? 1050 or something, yes? Yeah, see, y value here would be, x value is 100 and y value is 1050 or 1040 maybe. right? Y values would be the same. Instead, what do we do for the x value, right? So y value we are using the same, and then x value would be uh, x squared, which is 100. And then this one, 9 squared, 81. So 81 and this, what is it, y value, which is 1400, yes? Yeah. So 1400, so 81 and 1400. Make sense? Like that. So basically, y values will be the same, and then we take that corresponding y value for the x squared. Good. Right. Then guys, what are we going to do? We'll have to do the least squares regression line, which is, what's the least squares regression line? Yep. Y equals, no, a plus b. Mx plus c is in year 10 maths, right? Same thing, but we don't use that format. We use a plus bx. Okay, y equals a plus bx. Then guys, how are you going to find this graph? Use the CAS. How? You would use, what is it? You can apply, so basically you can include x. I'll show you how to get it in the CAS. Yeah. So next chapter, we're starting practice test for next. Okay. Yeah, we'll do practice. Bring tomorrow. Practice one. Yeah. We'll do it next. Next week. Okay. And then I think Tuesday is March 2nd, Tuesday. Sorry? March 2nd, Tuesday, right? Yeah, in 2 weeks. Is that where you have the sack? Yeah, March 2nd. You should be fine. Okay. I have it on my laptop. You don't have it? I have it on my laptop, but yeah. Why? What happened to your class? Okay, guys. Right. Now, how do you construct the square, x squared, and the y? Firstly, yeah, you don't have to do anything new. So you have to enter the data as given. Okay. As it was given, you have to enter the data. Now see, these are the values given. X and time is x. Yep. Height is y. So then you can put as you were putting the data to the CAS. And if you have a class pad, same thing. Yeah. If you have a class pad, same story. Remember last time what we did? You had to go to the statistics application and then enter the data. Okay, guys. So then having entered, what do? You have to use a squared format. So then with the next or new column, right? You have to use time times time column times by, or basically time column square root, sorry, squared, and then you can get the time squared, which is the x squared. Okay, everyone is okay with that? If it is class pad, what do? Okay. Do you have the textbook, Maha? Yeah. If you have a problem in how to enter in the thing, see, these are the ones. See. So basically, if you are having the class pad, yes. Right. If it is a class pad, yeah. What are you going to do? Uh, how you are enter the? Sorry, no, I don't know. I don't know much about the class pad. Yeah. Either you will have to go and check online, otherwise use the manual. Otherwise, you can learn how to do it from the beginning. So basically, you know how to do it. Yes, I think it's the same method. Control N. I don't know if it is the same thing. Is it Control N for a new? Uh, those are the steps. Control N and so on. And you are entering the data. Entering data is same thing. Yes. If you have a problem in that, go to the previous one and check how you are going to add the data. Anybody has a problem in entering data, it's in the previous one. Yeah, this is the one. In page number, for the crossfed, the page number is 174. I'm talking about the actual page number. Not in the PDF. PDF can be different. Right. Okay with that? Yeah. If anybody has problem in entering the data to your TI Inspire, so the information is page 173. Right? You go with Control N and add list spreadsheet and so on. Yeah. Right. Then we'll go back. Okay, guys. Now, right. Then Right. So as we were talking, when we uh, uh, when we realize that we have to get the square of the uh, x variable, or otherwise explanatory variable, then you have to find the regression line, right? Using the, what are the variables you are going to use? Instead of x, you are going to use x squared and y using the cas. Okay, right. Then guys, part B. What is the part B? Use the least squares equation to predict to the nearest meter the height of the base jump after 3.4 seconds. Right? Okay, guys, look at this one. Everyone. Use the least squares equation to predict to the nearest meter the height of the base jump after 3.4 seconds. Then what do we do, guys? We have to use the new regression line, which is with the x squared one. And then what do? We apply, or we substitute 3.4 squared, 3.4 squared. Then we can calculate it for height. Okay. So then we are getting 1,503 meters. Right. Any questions?
Wait, why is square 5 again?
Yeah, because why? They are saying we have to predict the nearest meter, the height of the base jumper after 3.4 seconds.
Yeah.
So then, which equation are we going to use?
The
New one.
the new one.
Yes.
Right.
With x squared, right? Because why? We recalculated the information for this one, for the straight line here, with x squared and y. Yeah, with x squared and y. How do we do that? Yeah, you go to the cas and you apply
Yeah,
x squared and y, right? Then you can get the regression. So this curvy one will become a straight line like this, right? Will become a straight line like this, and then we have to get the equation. So then equation is this, right? Then what we do is for time we are substituting 3.4, right? For the time we are substituting 3.4, then 3.4 squared, and then we can find the height. Clear or not clear?
Yeah.
Okay, Ma? Okay, and Sandil, you guys okay? Right. Then we'll go through the example 2, guys. Right? Now look at this one. Scatter plot shows that there is strong positive association between the fertilizer and the yield. Right? So our fertilizer use and the harvest, that's a positive. Yeah, of course, it should be positive. Right? Positive association. The next thing is, guys, apply a squared transformation to the variable yield and determine the least squares regression line for the transformed data. Right. The question. Okay. The question. What transformation are we going to use here?
Y squared.
Y squared. Right. Y squared. Why is that, guys? Now look at this. Now the change in x, for example, here to here is the x change, but y change here is this much, right? But later, what happens? X is changing this much, but look at the change in y. It is even dropping. And then in this case, the last one, change in x is that, but y hasn't really changed. So basically, the rate of change in y as it increases is decreasing. So then what are we going to do, guys? We are going to stretch out which variable? Y variable. Why? Because x is increasing, but y doesn't really increase. Yes, see the last one, it's the same. It doesn't even increase. Yes, it's quite the same. Right. So then what are we going to do, guys? We are going to stretch out the y. So then what would we use? What transformation? Y squared. Then when we use y squared, yes, again we are going to do the same thing, guys. With then what is how are we going to find the new regression line? New regression line will be x and y squared. So then our equation will be like this. Look at this. Y squared is equal to a plus bx. Okay. Yeah. This is a new equation. Y squared. Yes, that's the thing. Yes, that's the thing. When we get the y, so then now let's see, good question. Now look at this one. What happens? Now use the least squares equation to predict the yield of a plant given 6.5 milliliter of fertilizer. Then guys, our equation is this one, right? 2.29, fertilizer is 6.5. 2.29 times by 6.5. Okay, and 4.45. Then whatever the answer we are getting is, what is it? 19.34. Then 19.34 is equal to what? Y squared. This is y squared, meaning, how do we calculate the y then? You have to root it. Okay, we have to root it. Then we'll get either plus or minus 4.4, but yield can't be a negative value, so that it should be positive. So 4.4 kilos of, what is it? Yield. Yeah, our harvest is 4.4 kilos for 6.5 milliliters of fertilizer. Okay, done. Right. Any questions? All right, then we'll do some questions, guys. But you'll have to apply the CAS. Without the CAS, you can't do. Okay, guys. Do the question number 5. Yes.
Every time I take away my completely data and I write the same thing get what extra again. I'm feeling values from the show one about it.
I didn't get you.
Even exactly 10 years ago, they were practicing the hashtag photo. I deleted every single thing from it. I cleared everything, and every time I want to rewrite X, but, and when it comes back, and it's ignoring the data, I think. It's ignoring by-
Probably did you try with a new window? Yeah? No, remember go to that instruction in page 174.
For this,
Yes, in that.
and, make it-
Yeah, so in one, how do you go for a new one? In the situation, we enter the data into the dictionary. And that there's the color indicator. You know how to get the new window? Or otherwise, the problem is like you have a set oneness. You'll have a problem with CS for new one, or the previous one hasn't been created.
I don't know how to get a new one.
That's the thing. You have to get a new one. Look data into this name. Use the equation to get it. Only that, check. Do you have a spreadsheet icon?
Yeah,
Yeah, then tap the spreadsheet icon. Then you'll give you a create new file. So basically, is there a one called tab file? I mean, like tab called file icon or something?
um. With
Spreadsheet icon in the applications.
spreadsheet.
Is there an application thing? Yeah, there should be an application. Sorry? Yeah, in the icons, do you have? Sorry? How it looks? Yeah, you should have a file thing. And the top. So it was like this, yes. So
All about the statistics, how much is it right? You can just solve that one thing, so it's not the thing.
yeah, because this calculator. Yeah, otherwise, follow the textbook from the, where we started this lesson in chapter 3. It should be telling us how to get anyone. Right, otherwise, stay after the class, I'll help you. Okay, guys, then, did you do it? So, what's the answers, guys? Question number 5, yes? Yeah. Yeah, are you getting a linear line? Are you getting a linear line? Yep. Yeah, what's the linear line? Basically, you will get, yes, the equation is y squared. Yeah, so you have to give it to one decimal place, two significant figures, yes. Yeah, but that's just the coefficient.
The 1.44, that's the y-intercept.
Yeah, 1.4045. You sure? Let me check.
1.2 squared, yeah. Or 1.4.
Mm-hmm.
Well, this guy is going,
Sorry?
this very wide.
Yeah, what's it now?
Got it.
Mm-hmm.
Uses almost like in different letters instead of previous.
Okay, that's fine. Yeah, y squared, wasn't it 1.5 rather than 1.44?
Because it's only asking to write the coefficient. So the only coefficient in there is the coefficient of x. Which would be
No, we have to give the equation. Give it the equation.
its equation.
Yeah.
But I got the equation as 1.44 plus 3.2x.
Yeah, so then two significant figures. That
Yeah,
means,
but that's only asking for the coefficient, not the entire equation. So only the coefficient of x would be written into significant figure than the rest, because the rest is just an intercept.
I think we had write the other one also two significant. No, your point is also correct. So they're saying give its equation. Yes, yeah, this is not clear. Give its equation, write the coefficient, rounded to two significant figures. Yeah. 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 Basically, yeah, I don't know what others got. Sandhya, what did you get? 1 point, he say 1.44? Or would it be 1.5? Okay, guys, then y squared 1.5 or 1.44 plus what is the coefficient of x? 3.1 x. Yeah. Sandhil, did you get value for this one, the equation? Sir. Sir.
If I did the graph thing, it's not doing.
Yeah, you can, you should be able to do the graph. Yeah, something wrong with the data then. Yeah. Yeah, we'll figure it out later. Right. So then, were you able to clear the other data? Or still no, you are doing in the same, yeah, no, I don't think it will work. No. Okay, guys. Then part C. Use the equation to predict the value of y when x equals 9.
5.4.
5.4. Okay, so if we apply it, guys, y squared 3.1 times x is 9. So then 20, 29.3 or 29.4. Then we have to get the square root of this, which is 5.4. Right. This is the answer for part C. Okay, what do you have to do, guys? Make sure when you got the y value, 29 point, I mean, y squared is 29.14, then you have to get the square root, then y will be equal to 5.4. Right. Please do the exam questions. There are 3 of them. And guys, did you do 10 answer? Others okay? Maha, you okay? Still doing? Shamdil, are you done? Ken, are you done?
Yeah.
Right. What's the answer for question number 8, guys? T. Did you get it, Ma? No. Okay. Sandhya, did you get for question 8?
Yes.
Sorry?
Can you hear me, sir?
Yeah, did you get for 8?
So I don't quite get it.
Sorry?
I don't quite understand it.
You didn't understand?
No, sir.
Sorry?
No,
Okay. Why didn't you tell me then before?
I
Right,
did
so
tell you.
basically what you have to do here, guys. Akin, did you do it?
I don't think I got it, but I think I know how to do it though.
Sorry?
I know how to do it, but I didn't get it.
Uh-huh. Okay. So basically, Mahat, did you get it how to do it? Yeah, 8. Okay. What do you do? So basically you have been given X and Y, and also the plot has been given, right? And also we can see this one, what is it? Clearly, non-linear, yes, non-linear. So then, if it is non-linear, which transformation are we going to use? So they have asked us to do the, see, apply to X to linearize. A square transformation is applied to X. That means we don't have to figure out, but they have told us, yes. We don't have to worry about linearizing it. We have been told it to do it. Okay. If that is the case, guys, what do we do? Then we can simply apply X squared. That's it. Just a matter of applying X squared. Nothing to, worry. We can just apply it and then we can get the X squared. Let's say they had not told it us to apply the X transformation. Then what do? We don't know which transformation we are going to use. Then you need to figure out. How would we figure it out? So what we can see is, right, Y value is, look at the change in Y value, right? At this point, the Y value changed by this much, and also at this point, this much, and then X value has been what? Pretty consistent. Okay, but Y value is technically increasing at that point. So what we are going to do is we can say that we are going to apply the X squared. However, as I told you, we don't have to really worry about it. The reason is they have asked us explicitly to use the X squared. So what do, guys? You enter the X values and enter the Y values into the cache. Then next column you have to apply X squared, get the X squared column. And then you'll get, what is the X squared values here, guys? So 1, 4, 9, 16, and so on. Then it's a matter of applying the cache, and then you will get the equation. What is it? Was it the question? D or A? A? Sure?
Yeah.
260.
I mean, 263 because
It can't be 263. It can be.
no, because when X is 1, Y is already 264. So if X is 0, it would have to be higher.
Yes, but it will be linear, yes?
Yeah, but it will still be higher because it won't go like this. Because 263 is lower than 264. So it can't go up and then back down. Because anyways, 1 squared is 1. So it would have to be 310. The y-intercept would have to be 310, meaning It would be A. No?
You know the reason, yeah, your point is correct. But the problem is, Krishan, right? The problem is this. When you are going to linearize actually, we can't say exactly. So the point is like, this is 264, that's correct. Right? Then we can imagine, see something like this, right? Okay, it can be something like that. But when they use the transformation values, right, what will happen is x values are going to increase. I mean,
But then one spread is still one.
mm,
And if
yeah, but when
downwards trend,
yeah, but the thing is, the trend, it can the linear equation can be something like that as well. It can come below that one line, well, below the line as well, below 264.
if the regression is
You know what I mean?
yeah.
Other if the like, because it can change the other values. For example, if we go to what they have given before, now see this one,
Mhm.
right? The red line is going even. Now see, red line is going even further down, right? That is one thing, right? Going down further down, and look at this one, right? See, the lowest value is here, but see, intercept is here. So the squared line can change. Yeah, so when you apply the calculator, so however, it doesn't really matter, right? When you apply with the calculator, is that what you got? Without the calculator, you said?
Yeah.
No, without the calculator, you can't say. Okay. Yeah, without the calculator, you can't say that. Yeah, if you apply the calculator, guys, 29 point. Yeah, so yeah, so basically, guys, you can't do manually. You have to use the calculator. How do you do the calculator? Get this x squared, right? I mean, type this information x, y, and then put them into the data, and then get the x squared. So x squared will be calculated by the calculator, and then you'll get the equation. If any of you have any doubt regarding this one, yeah, so you have to go and check the previous lesson, which is, application. I think your problem is with the application of the CAS. So go to the chapter 3, see how you are going to do it. As I told you guys, it is in page number 173 and 74. And how to add the data values and things like that. They are in there. Okay, the next one, question number 9. Yeah, what's the answer for 9? This one you don't need the CAS. Maha, did you do this one? 9?
Can't bring a different answer.
What do you mean by different answer?
Everything, that's very, that's nothing in my answer.
You are not getting a correct answer. What's the answer you got?
603.
643. Okay. That means you have to get the square root.
Um,
Oh no, not square root. Mhm. Okay. Sandil, did you do this one? Sandil,
Which one, sir?
did you do question 9?
No, sir. I couldn't do it.
Sorry,
I couldn't do it, sir.
you couldn't do it?
No.
Yeah. Okay.
I'm pretty sure it's D.
E.
D. D.
What did you get, Christian? A. Right. So technically, what do we do? So this is easy, guys. So you have to apply x4 4x, right? Instead of x here, you are going to apply 4. Right? Now tell me the answer. Others, anybody who didn't do it, tell me the answer for y squared.
41839.4.
Okay. What about the others? Yeah, because everybody can do this one. Yes, Baha, what did you get?
First part last values, 41,039.
Akin?
For 9, yeah.
Sorry?
Wait, what are we getting the answer for?
Sandil?
So I'm doing it.
Tell me again. Sandil? Sandil, tell me again. I didn't get the answer.
So I'm doing it.
Okay. Yeah, good. Ma, can you find the answer for question 9? Mm-hmm.
Up to join, well,
Akin, did you get the answer?
I got D.
Sorry?
D.
E. Sandil, did you get?
I got A.
A. So when you simplify, what's the answer you got here for y squared?
Um, I got 41,839.
Yeah, 41,839. Yes, again, so you'll get this one. Then what do you have to do? Then basically you have to find the square root. So square root of that is 205, right? It can be either way. It can be plus or minus, right? But what they have given us is all plus answers. So that anyway, answer is A. Right, next one, guys. Question number 10.
I go for option A.
A.
So,
Okay. Okay, guys. Sandilana, can you get it? The answer for 10.
B.
E.
B.
B. Okay.
Yeah, it's B.
Yeah. Okay, correct guess. Right. Then answer is B. Right. So what you do is for the weight, you're going to apply 75 and then that's squared. So times by 0.238. Then you will get 3,709. All right, guys. Now we are going to the log transformation. Now, still, are you having trouble with this concept, transformation? Yeah, transformation. What do we do? We have been given what x and y values, yes. So we have been given x and y values. We have x value independent and y value dependent. Then what we do is with the original x and y values, right? If we plot it for x and y values, what we are going to get is yes, a non-linear line like this. This is the original value. This is the original values based on original x and y values. But because we are not really interested with the non-linear lines, right? We want to make it linearize, right? We are linearizing the graph. To linearize, we apply different options. Yeah, we are using different changes. What is the changes? Either we will, sorry?
what does it mean by log 10?
Yeah, I'll explain it. Don't worry. Right? So, in this one, we are to linearize, we are using different changes. Right? Krishan, is the other class there? No class? Okay. Right. So we will linearize the things, yes. To linearize the graph, we will apply different changes to x or y variable. Earlier, what did we apply? We squared that means we applied the square for either x or y values. So then with that, we linearize the graph. At this point, what do? We are going to find the log value. Now, somebody asked me like a log. What is log? What is log value first of all, guys? You are not there, yes, when we do log in the first lesson? Yeah, that's a problem. Yeah, but you have done them in year 9 and 10 maths. No? You haven't done log? Okay. In year 9, you are doing. Well, okay. All right. What is log value? Krishan, I think you were there.
It's log in. It's when you only take the power of the number.
Yeah, okay, I'll explain it. Now look at this. Anybody who has forgotten the log values? Right? Okay, so how do we do the log ones, guys? Let's say we have a number 100. Okay, then can we write this one as a power of 10? 10 square, 10 to the power of 2. And then what's the log value? Christian, 2. So log value, then we can rewrite this one. Log value of. Now look at this. Don't do anything. Okay, when I explain you have to look at the board. Other experiments you have to do later. Log value of 100 is 2. Then this 10 we are writing for the base. Log value of 100 to the base of 10 is 2. So similarly, can we write 1000?
But why is 200 on the top?
Sorry?
Why is it to the power 100?
No, not to power 100, power of 10.
You wrote log 10 100.
Okay, so yeah, what this means is log value of 100 to the base 10 is 2. Okay, otherwise simply you can forget about this one as well. Log value of 100 is 2, because why? In your study design you always apply for the base of 10.
Only base of 10?
Yes, only for base of 10. Okay, I can't recall anything that you had. No, you don't have anything else. Is it clear or not clear? No? Okay, shall I write another one? Okay, 1000. Take 1000. What is when you write this one as a power of 10? 10 to the power of 3. Good. Then what's the log value of 1000? So you can say if you want to the base 10. Right? Similarly, log value of 10,000. What is it?
4.
4. Log value of 10. 1. Log value of 1. This question, you have any idea? Log value of 1? 0. Okay? And then look at this. In between, so if you ask me what is the log value of 0? Log value of 0? Yeah, there is no value. Yeah, however, yeah, undefined. So, however, if you ask me, right, the log value in between 0 and 1, if you ask me the log value in between 0 and 1, what are those? All minus values. Minus. Why? See, this is 0. Okay? This is 0. How it happens is, I'll explain you. For example, if you ask me log value of, right, 1 over 100, which you can write as, what is it? Or the other way. Yes. Sorry, no. Otherwise, you can write 0.01. Okay, if you ask me, technically, log value of 0.01. How do you calculate? This one can be rewrite as 1 over 100. Meaning 1, 10 to the power of negative 2. Oh, sorry, 10 to the power of 2. So with the index law, you can bring it up. You can say 10 to the power of negative 2. So that means log value of 0.1 is, what is it? Negative 2. However, you don't have to worry about calculating it manually. You can use your calculator. Okay, now you can use log value of 100. Okay, log value of 100 is what? 2. Log value of, like that, you can apply the another one. And the other stories, you have to find the anti-log, opposite.
You do that.
That one still you can use the calculator. Okay, you have a button. And I don't know like what, don't ask me like, you have like weird calculators. I don't know, but I can show you in my calculator. I mean, the normal scientific calculator also you can use. It's actually easier rather than the CAS. Because CAS we have tried this. Yeah, I showed you when we were doing CAS. Do you have in the CAS
Yeah, I do have.
anti-log?
Isn't the anti-log just handy or whatever?
Sorry, question, is it this one?
Events.
Is it that?
It would just be shift.
Is it that? No.
No, it would be shift,
Yeah.
and then that log. Something like that.
No, I can't use. I will not use this. However, yeah, you can do shift tab. I can show you on this side if you want. So log value, look at this. Log value of 100 is 2, right? Like that you can do 1000 is 3. And then let's say if you want to calculate, you have in your log value, you want to get the normal number, right? Then what you do is basically shift and this. So then you get that one antelope. If you press 2, what will be on? Like that, 3,000. So you have the log value and you come back to the normal number, and then that is which we call as antelope. Okay. Right. So that's the log value. Now, guys, why do we use the other problem is why would we use the log value? So let's say you have a number like this. Look at this. Look at this. You have number like this, right? Too big, yes. Then what do? You are going to, yes, you are going to basically, yeah, shrink it. So earlier we were stretching, now we are shrinking. To shrink it, what do? I apply log. If you apply log, what is log value of this? 5. 5 because 10 to the power of 5, which is 5. Right? If you had similarly 1 million, that means it will be 6. So see, we are shrinking the values, right, by applying log. Okay, guys, now we go back to the lesson. Now, what we are going to do is, look at this. We compress O, we shrink the values because values are too high for X, okay? Values are too high for X. Why? Look at this. The X value is increasing, right? X value is increasing. But Y value, look at the Y value. At the beginning, Y value was like this, but later, Y value is only this much. Y value is decreasing. Yeah. Then what can we do, guys? Tell me an alternative method. We can apply y squared. Yes, we can apply y squared. That's what we did before. But in this one, what do? We drop the x value because x values are too high. That means what do? We apply log x. That's it. Right? We were having values, something like, let's say, x is, 1,000, 10,000, 100,000, too big. Then what do? You use the log x. So log x will be, what is it? What is log x, guys? 3, 4, 5, and so on. Right? Then you use the normal y value. Y as normal. Right? Then you get whatever the values, and you can now plot it. As a result, what happens? You'll get this linear line. Okay, similarly, guys, you do the same thing for y value. If the y values are too high, what do? Then you can apply the log y. That's it. And then you will plot it. Now, any questions that Maha, Sandit, Sandil, any questions?
Yes, sir.
Okay.
No.
Okay. Right. So example is, guys, yeah, look at this one. The GDP per person in dollars and lifespan in years. Right? GDP in dollars and lifespan in years. Right? Then as a result, what happens? They have given us very big values. See, GDP is how much? 10,000, 20,000, 30,000. So too big. So then what can we do? We can apply the log. So as a result, so they're asking us to apply the log for the x variable, and then we can get the straight line. So it's going to be log GDP, right? And then we can get the regression line by using the case. So once we got the regression line, now after that, what do? Use the least squares equation to predict the lifespan of a country with GDP 20,000. So what happens, guys? Now look at this. The equation has been given to us. I mean, we have to find it. 54.3, 5.59, and so on. Log times GDP. Then, guys, to calculate the GDP, what do? So we substitute 20,000 for this, and we calculate for lifespan. Lifespan is going to be 78.3 years. It's a matter of substituting the value, but the only thing is you have to get the log GDP value. So log 20,000 is how much? 4.2. Log 20,000, 4.3. Right? So log 20,000 is going to be, this one is going to be 4.3. Then you can calculate 78.3. Okay? Make sense? Others? Yeah, make sense? Right. Next one, guys. Example 4, applying the log y transformation. Log y transformation is this is about an infection. So look at this one. Like COVID, yeah. So as the days go on, so the values is going to increase exponentially. Like, remember what happened with COVID? So, one person will make another man sick, and like that. And then they are going to make other people sick, and they basically distribute the or make the other people's infected. So then it's increasing. So at the end, it is increasing exponentially. Yes. So then, what are we going to do, guys? So log y. I mean, we have to apply log for y, right? Because the dependent variable is very high. Okay. Then again, we have to apply the cas and get the values. And then once you got the equation, this is the equation. Now this one is interesting. Now look at this. They ask in part B, using the equation on day 13, number of cases is predicted as, right? Number of cases predicted as, what is it? So we will get 1.046 plus 0.227, no, times by 13, right? Then what do we get, guys? Here the answer 3.997. So this one is log y or cases is going to be 3.997, right? Then what is this one? This is the, yep, this is the log value. Then is this the answer? Then what do we do? You have to apply anti-log. 3.997 is actually power. It is approximately equal to 4. Meaning, what is it? It will be close to 10,000, yes? Which is, they have given us 9931. Right? Use the anti-log function. Right? Anti-log 3.997 is going to be that one, which is 9931. Okay, guys, any questions? Yeah, any questions with this one? And also, if you have any problem, in using the cache. Yeah. Yeah, do question number 4. If you don't have the cache, you can use even the normal calculator. Okay, guys. Did you find the values for this? Yeah, log y equals to, what's the answer? 100. Yeah, so what are we trying to do here? Normal, the log value or anti-log? Yeah, we are finding the anti-log, which is this one is 100. Okay. Maha, did you do part B?
Um, does that look different from what we did?
B. No, A, what did you get? So that's what I said. That's why I said this is not log value. You have to find the anti-log here. Why? Log value of the y for the base 10 is 2. That means you are finding the anti-log, right? Yeah, so that means anti-log you have to apply. B, Sandil, did you get for this one, B?
Is
For
it
part B?
218?
Sorry?
Is it 218?
200?
18?
218. Yep. So you got the same question?
118.8.
Yep. Then C, then you have to substitute X. Log Y is equal, did you do this one, Ma? So you have to apply, you have to substitute 1.254 X. Then what did you get, Christian?
1 million.
1 million. Log Y here is going to be 6. So anti-log of 6 is what? 1 million. Right. Sandil, did you get for part D?
Is it 0.8?
0.8. 0.8. What did you get, Christian? 0.8. Yep. Correct. So Log value is what? Log value we are getting negative 0.0848. Then for the anti-log of this one, you have to get, you have to press anti-log and then execute. You are getting 0.8. Right. Yeah, again, I can't ask you to do this one because you guys don't have the. Yeah, do question number 9 and 10. Okay. Yeah. Right. Okay. So, Ma, you done? Sandil,
Yeah.
what's the answer for question number 9, guys?
E.
E. Ma, E. Sandil,
Yeah. E.
E. Everyone is okay with that. 10,
A.
Ma.
Sure, this one.
Sandil.
A.
Yeah, basically, if you're not sure, I can help you. What is this? Now, this one, what do you have to do? Normal log value or anti-log? So, log value of, we are getting share price, which is Y. When you apply, the month is, what is it? 14th, yes. So that means you have to times it by 14. So then you are getting, when you simplify this one, you are getting 2.09. Yeah. Then for this 2.09, right, you have to use the anti-log. Anti-log of 2.09. So it will be, what is it? More than 100, 123. Yep. Actually, this one you don't even need the calculator. Yeah, because something which is greater than 2, of course, we know. Antilog of 2 is 100. So more than 100 is, there's only one answer. Which is, yeah. For homework, can you please do, because you guys don't have, I mean, either you don't have the CAS or you don't know how to use it, or you have problems with the CAS. So then try these questions at home. Question number 2 to 8. Okay, for homework. Okay, guys, right.
Trial balance questions or something that I can
Trial balance, yes.
send them,
So you mean like,
including all the letters. Because we did the practice set today and get exactly balanced trial balance. Yes.